Okay, so today we're going to start the last section in this part. We're going to do the last section in this part, which is relations. These are on page 153 in your book. And then I passed out this study guide for you, front and back. So everybody should have one of those. So we're going to go over this homework, which is on the board on Monday. We'll review on Monday, and the test is on Tuesday from the last few sections, okay? And then that will be the last part of this chapter.
We have 2 tests on Tuesday.
Okay.
You can't have more than 2 tests.
Is there a rule that says you can't have more than 2 tests on a day or something?
Yeah, but chances are we'll be pushing ours till Wednesday.
Okay. So anyway, we're going to start section 10 here. All right. It's relations. So you need to understand what a relation is before we can start. So if you look on the front, it's page 51 at the bottom of your sheet. A relation is any set of ordered pairs. The set of first coordinates in the ordered pairs is the domain. Okay? So when you have a relation, it's a group of ordered pairs. Michael Moody, give me a relation. And I don't care what. Just give me one. Give me a relation. 1, 2, 3, 4, 7, 8. How about -7, -8? This is a relation. All a relation is a set of ordered pairs. What's important is that you understand that the first coordinate, your x coordinate, is your domain. Okay? That's your domain. Your second coordinate, your y coordinate, is your range. Okay? X is the number that you're going to put into your function. Y is what you're going to get out. Okay? Now, this is important because it's going to give you a bunch of relations, and it's going to say, tell whether or not it's a function. Okay? Not every relation represents a function. Not every relation represents a function. So the way you can tell, there's 2 ways. The first way is fairly simple. These are all the x values, the first coordinates. None of those can be the same. As long as none of those are the same, you have a function. I'll say that again. As long as your first coordinate, your x coordinates are all different, they're not the same, you have a function. Did someone have a question? If you have in your relation 2 x coordinates that are the same, you don't have a function.
What is it called?
If it's not a function, it's a relation, a functionless relation. There's not a specific name, but it's not. But all functions are relations. Not all relations are functions. All right.
Please say that again. Not all what?
Not all relations are functions. This one is that Michael gave us because notice my x values. None of them repeat. They're all the same, so that's fine. The second way to tell is by graphing the relation. Okay? So, anybody know what that line is, what that function is? Who can give me the equation for that linear function? I'm sorry, assuming the drawing didn't go through. Assuming that goes through the origin, I'm sorry. Y equals x, but in functional notation, it's f of x equals x. You have a slope of 1, an even slope, and you got no y-intercept. It goes through the origin. Right, that's the function of f of x equals x. Is this a function? Well, here's the other way to tell. It's called the vertical line test. And I think I talked to you about this the very first day we did this section. I mentioned it briefly. But if you can draw a vertical line on your graph and only intersect the graph in one place, you have a function. So notice here, every vertical line you draw only touches that graph in one place, only intersects that line in one place. If that's the case, you have a function. Okay? If, and I think again, the very first day, I talked to you about this graph here, right? if I had this graph, notice that if I draw a vertical line, I'm going to touch that graph in two places. Also, I have two x coordinates that are the same. This fails the vertical line test. This is not a function. So if you can draw, if the function is such that you can draw vertical lines and only intersect the graph in one place, you have a function. If you can have any vertical line we were going to intersect it more than once, you don't have a function.
So even if the line's like this, like, it's still a vertical line.
Yeah, if you can go like this.
Yeah, that's what.
As long as this isn't vertical, I drew that weird. If it was
Yeah.
just slightly,
Yeah,
yeah.
I know.
As long as it's not vertical, yeah. That would be a function.
That's cool. Ready for it?
Okay. Anybody have any questions on a relation, a function, or a vertical line test? Everyone understands the difference between domain and range at this point, right?
Yes, only the X and
Okay. Well, let's do some of these and make sure that you understand them. All right. So, number one. So we're going to go, guys, we're going to go around the room. So everyone's got to pay attention. We're on this worksheet, the one that says 51 at the bottom. And I'm very at the bottom where it says give the domain and range of each relation graph below. Is the relation a function? Austin Farrell. Number one, what is the domain? And we're going to assume these are all squares, so each square is 1, okay? So from the origin there, 1 to the right is 1, that way. So what's my domain? Negative 1 and 1. Those are your x values. That's the domain. Crystal, what's the range?
Wait, can you explain that?
Yeah.
I don't understand. I don't get
Very confused.
This is, everyone's looking at the same, make sure you're looking at the same graph that I'm looking at here, but I have, you don't see that. See, those are the 2 points that you see on your graph there for number 1. Okay? Your domain is the x values, 1 and negative 1. Your range is what, Crystal? Those are your y values. Negative 1 and 3. That's all they're asking for. They want to know, do you know the domain and range? The domain is your x value, the range is your y value. And then finally, Jared, is this a function? Is this relation a function?
Yeah.
Why?
Because if you put vertical lines, it doesn't touch you more than.
It passes the vertical line test. And right, none of those two x values are the same. Okay. Yeah.
If it's like 1 and then negative 1, is that like the same? Or is it technically?
Two different numbers.
So that is different?
Yeah, 1 and negative 1 are different.
Well, no, but that's-
Oh, I mean, for a relation, you mean? If you have a set of ordered pairs? Are you saying, like, hang on, let me make sure I understand what you're asking.
Yeah, I'm asking.
Are you asking, is that a
because
function?
it's the same number, but one's negative.
Right, now those are different numbers for a relation. Okay, so that's still a function. Okay? Okay. Morgan, number 2, what's the domain? Guys. What's the domain? All right, I'll wait till Crystal and Jared are done because I can't talk over people.
Sorry, I'm trying to explain it to
Okay. If you have a question, ask me. Don't ask your neighbor because nobody else can hear when I'm trying to talk. I know I appreciate you guys trying to help each other, but
I'm still confused on the domain.
on the domain, it's
Like,
whatever
number
you're.
one, how is it negative 1 and 3? That makes absolutely no sense. Wouldn't it be 1 and 3?
What is if you were to plot, Jared? Look at this.
Oh,
If you're gonna
okay,
plot
never
this.
mind. Yeah, Courtney Thorne just explained it to me.
Your two x values are your domain. Your two y values are your range. Okay. All right. For number 2, I'm sorry, Morgan, I couldn't hear before. So what's my domain for number 2? It's negative 2 and there's 2 points. Yeah, negative 2 and negative 2. They're both negative 2, both those points. What is your range, Courtney Hellman? Negative 2 and positive 2. Right. Does everyone see that?
I think they want the whole range and the whole domain as an interval.
That's not what they had in the master, but they just wanted the points. But
Oh, because that's, in the example, they have the range as a, it goes from negative 2 to 2. For
okay.
example, A, B.
Okay. Well, Mrs. Novicka,
Wait, so number one, how come people are only saying 2 things other than 4?
all right. What I'm doing is the first question I was asking you guys is, what's the domain for your 2 points here? I wasn't in these first two. I wasn't drawing the graph. Do you see how I just put the 2 points up there? And then I put these 2 points up here. So if I just have 2 points, my domains are the x coordinates and the y coordinates. If I draw a graph, like if you look at number 2 here, now I guess I'll draw it as a graph here, like this. Do you see that? Does everyone see that graph for number 2? What they're saying is, what are all the x coordinates in that graph? Well, it's from -2 to 0. From -2 to 0. See how all the, in this particular graph, all the x's are between -2 and 0. All the coordinates in there.
Wait, so that'd be -2 and -2, right?
I'm confused now.
Alright,
Wait, I
I'm
know,
at-
because it moves -2 and -2 down.
I'm saying if you look at all the points on this graph, all the x values are between -2 and 0.
So could you put like a little like that thing instead of like a comma? So it's like
I'm sorry.
never mind.
I was first plotting that
How is
point.
it- I'm still confused.
That's what.
How is it
Here, let me-
-2 and 0?
Isn't it negative 2?
Hang on.
No, yeah, that's what I thought.
It's negative 2, negative 1.
That's your graph there.
Negative 2, negative 2, not negative 2.
Well, this is your x value here. What's your point there? 0, 0. And here it's goes from -2, 2, and then it goes back over to 2, 2.
Isn't it like,
So what we're saying is, if you draw the whole graph, your domain all of your possible x values in there. So for anywhere from -2 to 0,
isn't it negative 2, negative 2?
that's your range. Range is the y values.
No, like your first point says 2, negative 2. Isn't it supposed to be
Oh,
negative
where's
2,
the,
negative
so
2?
for number 1 it'd be
Yes.
what?
Okay.
Starts at negative.
Is there anybody that's still not? If you're still not clear, you got to ask.
This is a
I'm
negative
not
and
clear.
negative.
What part are you having a hard
I
time?
It goes from, that's the y, going up to the other side.
This is your y's
Oh, okay.
here.
Oh, okay.
Those are your x's there.
Alright, -2.
Okay.
Negative,
The horizontals,
you know,
and then your
So
y's
you
your
just
vertical.
put
Negative
the
1 and 3.
numbers versus range.
So if you're talking about the range of the whole graph,
So
It's-
then you write that as a point.
So negative
So
1
since
and 3.
it's from negative 2 to 0, so you write those as a point? Because you said,
no, I'm saying that they were points. At first, I was just plotting the points.
no, right, but I'm saying your
I see,
little
I see. Alright, so
parenthesis, negative 2,
negative 1,
comma,
3,
0,
negative 1, 1.
parenthesis. That, isn't that the,
That's the interval that it goes over. My domain.
right, so you have to write that as a point?
He gave me.
It's not a point. We call it interval notation.
Well, that looks like a point.
Right. I understand that.
Well, that's,
That's how you write. That's how you write for interval notation a point, or a domain or a range, an interval. In other words, in this one, it actually includes. All right, listen up, guys. All right, let me show you how to write these intervals. Okay. If a point is included, if a point's included, we use parentheses. If a point's, if a point is not included, we use parentheses. If it is included, we use brackets. Didn't you do this when you guys did this at the beginning with when you number lines this year? I'm not crazy, right? So if you have a number line, you guys did these before, right? And let's say you graphed something like this and it was -3 to 2. You did something like this in the beginning of the year, right?
yeah, well,
You said the interval, what was the interval? The interval was, if it was included, it was -3 to 2,
we
right?
never did the different thingies.
No, now we're adding it to graphs. I'm just saying, but you've seen this notation
No,
before.
no, we're saying
No,
we
Mr.
did
Vickers,
the open
wait.
circle to this thing with the little line or a closed circle if
Right.
it's included.
And I'm saying if it's closed, I use the
But
brackets.
we didn't use
All right, well, so I'm telling you now. So if it's closed, you use brackets. If you have this, guys, If it's open like this with the closed circle, then it's negative 3, 2. That's your interval in here. If it's including these, then you use the brackets. If it's not including them, you use,
How do you know if it's included or not?
well, for a number line, it
No,
would
we're not talking about for a graph.
be, in the graph, it's the same thing. See these closed circles on your graph? Those are closed circles. So they're
we
including
have
those.
open circles in graphs?
You will eventually, but you won't now.
So we're always using brackets?
For now. I wanted to say for now, and then two chapters from now, because 2 chapters from now you're going to have open. So I
But
wanted
you're
to.
using parentheses.
Yes, I wasn't originally going to do any of that. I was thinking we were just doing the domain and the range of the points, not the whole graph. So, all right, guys, let's all move on to number 3. I'm going to do number 3 for everyone, and then we'll watch. It goes like this. Does everyone see that? That's the way number 3 goes. Okay? My domain here is all x's. Notice there's an x in every value. It goes on. Okay? So my domain is from negative infinity to infinity. Okay? All numbers x.
What? How's infinity?
Oh.
I have an x forever. You see there's little arrows there. Those arrows tell you it goes on forever. Okay? So domain's all real numbers. Does everyone see that?
Yeah.
Okay. Now for my range, what's my range here, Jared?
What?
What's my range?
Where are the points?
There, it's on the line 2 and negative 2.
So range would be 2 and negative 2.
But isn't it
1.
No, but on our graph it looks like it's going through 1.
Yeah, it's going.
Oh, I drew it through 2 up here. I can't. There's no numbers on here. I'm sorry. So yeah, but wherever you drew it, but you can see the point. The range goes from negative 2 to 2. Is this relation a function?
Yes.
It is a function. Good.
But
I'm listening. I can look. What? It passed the vertical line test. There's no place you can put a vertical line on that graph that will touch it in more than one spot. There's only one x value for every y value. What about number 4? So now that we're clear on this, number 4, Courtney Thorne. What's the domain?
the domain
So,
is this one like the x or
The x. The domain's the x values.
okay, so would it be, 2 to 4?
Well, it looks like from my graph, it looks like 1 the first square. It looks like 1 to 3. Does it look like 1 to 3 to you guys on yours?
Yeah, I guess that makes sense.
You could have been 2 to 4.
Then 2 to 4.
It depends on how you number these. But if you're Jared, please. If you're counting them by ones, it's 1 to 3. Okay, Michael Moody, what's the range? Here's something important because Claire, you asked about the parentheses. If infinity is never included, so that will always be the open. So just so you guys are aware of that, you never hit negative infinity or infinity, so those are always open. Is number 4 a function, Maggie? Why not? Okay. Listen, guys, listen up. I don't know what numbers in the homework are which, but do these ones that are range, vertical line, test, all that, and then when you get to the ones about absolute values, stop. Don't do those. I'll explain those on Monday. We'll do those Monday. I thought I would get further, but so you don't have to do that part of the homework tonight.